So this is one of the Leetcode hard problem. The problem number 2035, partition array into queries to minimize some difference. Okay. So what in this problem is given? We are given one array. We need to divide that array into two subsets, and the length of two subsets should be equal. Minimize the difference. Okay. So let's suppose we are given 3, 7, 3. So we need to divide it exactly into two halves. Thus both halves contain equal number of elements, and the difference between their sum should be minimum. Okay. So here what is given? We are given 3, 7, 3. So according to the problem, what we need to do? We need to generate two subsets. One is this, one is this. This S1, suppose is S2. We need to minimize this. S1 minus S2. Absolute difference should be minimum. Right? That is what it is. Now with this we can generate any number of possible combinations possible, keeping in mind that both should contain equal number of values. Other possible combinations can be like something like 3, 3 in one, 9, 7 in other. One possibility can be 3, 7 and 3. Keep in mind both should contain equal number of values. I mean equal number of contents, and we need to minimize this. So this is the whole problem statement. Now we can reduce this problem something like this. If we say S1 plus S2, whatever, always be equal to the total sum of whole array, right? This is always true. So here S1 minus S2 is given. Can we replace S2 with something like this? Total sum S2. Right. Go take this but on sorry, we can replace this S2 with something like S minus S1. Right, we can replace this S2 with something like this. So this will become something like 2 to S1 minus sum. Our problem boils down to this part. This we need to minimize. Right. So if we can see here, this is constant, this 2 is constant, and this S1 is only which can varies. And to minimize this part, suppose we need to minimize this, what should be the value of S1? How we can minimize this? If we think, then this S1 will be as close to sum by 2. Then we can minimize this whole part. Right. So if this S1 is as close to sum by 2, then this whole 2 into S1 minus total sum is minimized. Now our problem boils down to finding S1 as close to sum by 2. Right. So now our problem is this. From here we move to here. So we will take this as our current problem. So I am doing everything. Now I remove this. Okay. So now we want this one as close to 1 by 2. Now, what is S1? S1 is basically all the subsets possible. Subsets possible. Subsets possible of length, and we need to keep in mind the length also, because earlier, as we have discussed, we are dividing into two equal halves, right? S1 and S2. So if the total length of the array 2n is what is given, if you see here, this is given 2n, right? We can take n also, then in that case is n by 2, but here we are considering 2n. So this should be n and this should be n, right? So S1 should be, as of S1 should be, we need to generate all the subset of size n and want to make the sum of all those subset possible as sum by 2. Now, here many people are thinking, what is the subset? If you have previously gone through the problems of repeat backtracking, then you are quite familiar with the subset, subsequence, and substrings. But if you are not, then I will just give you a small example of that. What is the subset? Suppose this is our array 1, 2, 3. If we generate all the subsets of this, what would be 1, 2, 1, 2, 1, 3, and 1, 2, and 0 will also be one of the subset. So these are all the subset. In questions asking, we need to find the sum of all the subset. So this will be sum 1, this will be sum 2, this will be sum 3, will be also 3, will be 4, this will be 2, 3, 5, 1, 6, and 0. So as we can see, with three values, we are generating actually 2 to the power the subset. So if we generalize this, so for n number of values, it will be 2 to the power n subsets will be generated. Right. So now again, moving back to the same problem, what we're discussing, we need to find S1 as close to sum by 2. We need to find S1 as close to sum by 2, right? So now our n, that length of the content or the size of that should be n, what we have discussed, right? Now if we go with the DP approach of or the brute force approach of generating all the possible subsets here of S1, that if we generate S1 for our arrays 3, 9, 7, 3, we want to generate all the subsets possible of length 2, right? That is one approach. We can like do something like we can generate 3 9 in 1, 3 7 in 1, 7 in 9 3 in 1. These are all the subsets of length 2, right? Suppose if there are large number of values, what I'm saying, suppose this n is as of now is 4, but suppose n becomes around 40 or n become around 20, then we need to generate 2 to the power 40 or 2 to the power 20, something like this, which is not very optimal in our case to generate all the possible subsets and find the maximum of these, which is as close to sum by 2, right? So that's where meet in the middle concepts come into play. So what we will do instead, we can divide this S1 itself two halves, left half, under is right half. we can divide this into two half, left half and right half. Okay. Yes. So now what we will do, since as we have discussed earlier, it's quite not optimal to generate all the subsets and find their sum and make it as close to sum by 2. So instead what we will do, we will divide this S1 into two halves. Basically two subsets. This S1 will be further divided into two halves, left half and right half. See, suppose there are n number of elements in arrays 20 and we want to generate all the subsets, then total will be 2 to the power 20. If we divide this n into two halves, one contain 10 elements, another contain 10 elements, then this we need to generate 2 to the power 10. Here we need to generate 2 to the power 10, right? Which is obviously less than 2 to the power 20. So this part is much more optimal than doing this. This is the whole concept of this. Why we need to divide into two halves. We're actually doing the same thing. Here also we need to find all the subset to add their sum. Here also we need to find all the subsets at their sum. But with this, much more optimal. Right. Now we will divide this S1 into two half, left half and right half. Now one thing we need to keep in mind here, that here is one constraint we are given. This S1 this should contain exactly n elements, right? As we discussed here, like here also we saw, here we are discussing the S1 plus S2 contain n elements, this contain n elements, so total is 2 to the power n, 2 into n. So this should contain exactly n elements. Right. So if S1 contain exactly n elements, so suppose this is one subset, this is another subset, right? And this both combined make S1, right? Suppose let's say example, here 3 is there and 9 is there, here 7 is there and 3 is there. So if we choose 3 from here, so we have already chosen one element. So from the right half we need to choose n minus 1, right, to make it equal to n, because this should always be equal to n, right? It can't be less, can't be more, it should be exactly equal to n. So we are seeing that while generating the subset, we also need to keep in mind the length of subset generated. We need to keep a track, like how much, what is the sum of the subset generated using 0 length, 1 length, 2 length, something like this. So we need to keep this in mind. And here also, if we generate the right half also, then also we need to keep in mind, we need to keep the length. So for this length, either we can use hash map approach or we can use array approach. What like array approach, we can also use hash map. What I'm talking about arrays, like this will be our array. This is index 0, 1, 2. Index 0 will contain all those subset sums which are of 0 length, generated by 0 length. This will contain all those subsets generated by one length. I mean, we should take exactly one element. This will contain all those subsets which is generated by taking two elements of that particular array. Suppose this is our, again we take the same example, 1, 2, 3. So if we see here, so like all the subsets possible are 1, 2, 3, 1 plus 2, 1 plus 3, 2 plus 3, and 1 plus 2 plus 3, and that is 0. So if we see here, for 0 length, all generated are 0, right? Only 0. For 1 length is 1, all the subsets generated are 1, comma 2, subset sum generated are 1, comma 2, comma 3. We see for length 2, all the subsets generated are 3, 4, and 5, right? These three. And if we see for length 3, subsets length generated are 2 plus 1, 3, 6. So this is how we need to keep track of the length, and this will be a list. So each index will contain a list. Here, with that we can keep track of the length. Why length? Because as we have discussed earlier, if we are choosing one element from left in one subset sum from left, then we have to choose n minus 1 subset length, right? If that is not clear, we will discuss it again once. Like as we told, one is there, one should be of length n. So we are trying to generate it into using two half, left half separately and right half separately, right? Left half also, like suppose if s1 is of length n, so left half will be generated, left half subset sum will be generated from 0 to n, 2 values, taking 0 to n by 2 values, and right subset will be generated by taking from n by 2 n by n values, right? So obviously if we generate all the subset sum from 0 to n by 2 of our array, so it will contain all those elements, and this will also contain all the subset sum, right? And we will be tracking the length also, like as we discussed earlier, for 0 length, what is the subset sum? If the length is 1, then what is the subset sum? How much subset sum is generated? If the length is 2, how much subset sum is? You can see for length 2, and 2 means we are taking two values to generate that sum, subset sum. So if you see here 1 plus 3, 1 plus 2, 1 plus 3, and 2 plus 3, we are taking exactly two elements from this array 1, 2, 3. Yeah, if we take all the three elements, then length will be 3, and we're taking all. If we're taking nothing, then this. So like this we need to generate. Again, why? Because if we have taken one element from this, then we need to take exactly n minus 1 element from this, right, to make it equal to n, because our sum, the number of elements in sum should be exactly equal to n. And basically what is left and right, these are both subdivided part of this, right? Now, so if we can generalize this, if we take k elements from here, then our right should have n minus k elements. So that's why this online tracking is important here. So suppose we have taken 1, right? So from we have first taken 1. So from 1 we will get, so we need to take corresponding n minus 1 from here. Now this, I think this why we are tracking the length of the element, like long subset sum is clear. Move to the meet in the middle part. So meet in the middle part is actually what it says. Will remove this. So as we were discussing, we need to make this sum s1 as close to possible sum by 2, right, as we have discussed previously. So suppose from left we got sum a of length will be the, I mean, the number of elements which are responsible to make this sum. Suppose A. So in the right part, obviously this will be the right part, number of elements n minus A. Both should make as close to 2, right? Because that's what we want. We want one to be as close to sum by 2, right? So right will be something like, what will be right? Right will be something like sum by 2 minus A. This is what we are looking. So we need to find a value in our right generated which is as close to sum by 2 minus A, right? So suppose from left to subset sum generator, if we got something like this, 0 length will be 0 of one length. If we got as 1, 2, 3 length, we got something, so 4, 5, like this is from left we got, this is from left, and if from right, suppose we got something like this, for 0 we got something 0, for 1 we got something like 5, 4. Let's say this is the same second example, and right from 1, from 0 we got this, from 1 we got this, for 2 we got something like 0, 1, 2, and suppose from 3 here we got something like 8. So these are the length responsible for this subset sum. So these are the length and these are the corresponding subset sum possible. So suppose from left, if and suppose our S1, what we have, this should contain exactly n elements. So if we taken 2 elements from here, then obviously we need to take n minus 2 to make it exactly to n, right? Suppose this we have taken from left, so this particular list we have taken that contains, that is a combination of 2 elements from a subset. So from right we need to look for exactly that particular count of n minus 2, right? That list we need to take, right? Because this from left and right should always be like equal to n. Okay. Now if now I think this part is clear why we are taking the length, why taking 2 from here and from here. So if we generalize this, if we take k from left, k length from left part, then from right part we into for n minus. Now suppose from left part we have taken a, the subset sum is a, and from the right part we need to find, right? Obviously we know that this and this will be as close to sum by 2, right? This is what we are making, this is S1 only, right? This is S1 only, so we are making this as close to sum by 2. So what will be the right what we need to look for and write, we need to look for something close to sum by 2 minus, right? Suppose our right, after taking length and everything, we got something like 1 4, this list we got, this subset sum list we got 1 4 7 12 13 and 14. This is a list that we got for n minus k, right? And from right, and we are looking for 8 here. This right is 8. This is the right list. Actually, this is not right. It might be confusing. This is a right subset list. This is a list, right list. This is a right list. Now we need to look for 8. So we need to look for 8 here, and obviously we need to look for 8 here. So we want something close to 8. It can be that is very very good for us, but there are certain possibilities right here that element can exist here, exactly 8 will exist here, or some element exists which is as close to 8, right? So what here we are looking for? We are looking for element as close to 8, or if we think we are looking for something greater than or equal to 8, it can be less than also. Less than is also possible, but this is actually what we have already have an inbuilt algorithm for this. This is what we're looking. We're actually looking for a lower bound, right? Right. Mm. This should be sorted. We need to make it sorted before applying the lower bound. This right list should be sorted. So when we are looking for an element that is greater than or equal to 8. So if we apply a lower bound here, what is the index we will get? 0 1. You see here 1 4 7 12 13 14, right? So we are looking for an element that is greater than or equal to 8, right? We are looking for as close to 8, basically as close 8, as close to 8. So if we apply lower bound on this, we will get 0 1 2 3 4. We'll get this 3. This 3 we will get, right? This will be our index, right? This we will get, right? We apply lower bound on this index. If we move further from this, we will get 13 14. This obviously we are moving further from it, but there's also possibility this number is also close to it, right? Because 8 will be something here like this. So we need to check for both this and this, idx minus 1, whomever it is close. So our answer will get from these two indexes, right? So from lower bound, we will pass our what is required in the right side. Here is 8, and we need to pass that particular right list here. Or right list will be passed. We will get one index, and with that index, what we need to do, as we have previously derived the formula, we need to do this This is S1 minus total sum, right? This is the total sum. Absolute we need to find. So this S1, what we have done, we have divided into two halves, left half plus right half. Left one by one, we are iterating left. Here we have chosen A. Right we got from that particular lower bound. So from right list, we will get that particular lower bound. So this will be our sum one. This will be our, we need to find the minimum of all this, right? So two indexes we need to check. One is index and one is x minus 1. Right. So if you see in this problem, there are multiple concepts like involved. One is directly decrease involved to generate all the subset sum. Another is binary search is involved, lower bound. There is it in the middle. So these three topics are involved in this problem. So that's what make it very hard and also a very lengthy problem to solve. I think that is whole of this problem. So let now back to the code. So this is the code here. So one by one, I will get it through. So first, this part of the code is just for finding a lower bound. Those who are familiar with binary search lower bound, they will exactly find this very intuitive and very like normal thing. If you are not, then we need to revisit the binary search and to get to know how to find the lower bound. This is for generating subset sum. As we told, left half and right half we are generating for S1. So this is again a classical DP approach, or we can say the backtracking approach, but it's the backtracking approach to find the left sum and right sum. If you see here, we are making one generate subset sum. We are taking a start, we are taking end array. We need to also get the count for the subset sum generated. So that's why as if you go here, we have we are generating a list like this for 0 length 0. So this is what basically it is. This is the count, how much length we have generated, and this is the current sum. So this is the base case. When we reach the end, then for that particular count, for that particular length of element, we need to add the current sum. Now this is simply each element can contribute to that particular subset sum. Second option, sorry, the first is each element cannot contribute to that particular sum. If that element cannot contribute to that particular sum, then we simply move the index. Count will remain same because we didn't take in any element, and current sum will also remain same. Because if that element is contributing, obviously the count will increase because now we are adding one element, right? The length of that particular array is increasing. Also, the sum will also like increase. So this is the simple backtracking. And what we are doing here, we are just simply calculating the nums by 2. Here we are calculating, this is just simply nums length by 2. We are calculating the total length of this nums. This is the total sum of fold length. This is the target as we have discussed. We need one as close to sum by 2. So this is sum by 2 only. So this is 2 array. We will pass one in one array. We will get the left sum and then we will get the right sum. Indexes will give us the count of like how much length subset sum we generated, like of 0 length, of 1 length, of 2 length, of 3 length. So this array will help us to keep track of that. We can also use the hash map technique also. Here we are just calling that particular subset sum method. So as you can see, we need to generate the left part. So for left part, we are passing from 0 to n nums here, and for right part, we are passing from n to nums by length. If you see here, our n is nums length by 2, means half. So for first half, like with the help of first part, like with the help of first half, we are generating left, and with the help of right half, we are generating right. Now we will, as we can see, as we have discussed, for each left, we need to find a corresponding right value, right? So we will get all the subset sum here along with their length. So if you see I of left length, this with the right length as we have discussed. So for 0 length, and corresponding right length should be n minus I. So for 0 length, subset sum left will be this. For n minus I length, corresponding subset sum right will be this. Right. Now since we need to apply lower bound, that is binary search, so we will sort the subset sum right collection or sort. And now we have gotten all the subset sum left of that particular length, and we also got the subset sum right of this particular length. So we will iterate all the subset sum left one by one. We will find the corresponding right target minus as we target is total sum by 2, which is sum by 2, right? We will find the lower bound, right? This we are basically just we are finding the lower bound, and this is just the boundary checks. Since as we have discussed earlier, why we need to check for index and index minus 1, because our answer can lie in both. It can be index also, it can be index minus 1 also, right? So subset sum, same formula as we have derived earlier, 2 into total subset sum minus total sum. This is what we have derived earlier, method absolute. So subset sum 1 will be, already we have taken the left sum, corresponding right sum we will get using this. We will find one minimum here. We will also check for index minus 1. This again, this check is only for boundary conditions, since we can't do index minus 1 if our like index is 0. We can't do this part. So same thing, and then we will return the min.